Here's our introduction to congruent triangles. Here we have a hippopotamus, so they're calling it a hypotenuse. So you can remember that that's really called the hypotenuse. On our agenda, we're going to go through some pictures and see if two triangles might be congruent to each other. We'll write congruent triangle statements. We'll see what corresponds, so which parts match up, and then we'll have some practice. So are these congruent? Well, I see that those are both 5s and those are both 4s and those are both 7s. So I could put congruent marks on all of those. So I would say maybe. Let's look at this one. I still have the 5, but then I have 4 and 6. So these are definitely not congruent. Here we have a 30, a 40, and then we have the obtuse angle on 110. So all of the angles are congruent, so maybe. Oh, but then look, these are the same angles, but this is a small triangle and this is a big triangle, but it's showing right now that they're not congruent. They're not exactly the same. So this would be a no. So if I went back to the last page, I'd have to say no. Are these congruent? Well, let's follow the congruent marks. I have 1 slash matching with a 1 slash, 2 slash, and then my 3 slash. So all 3 sides are congruent. And then I have the 1 angle matching with the 1 arc, and the 2 matching, with the 2, and the 3 arc matching with the 3 arc. All of the pieces are congruent. So yes, I would say that these are congruent. Are these congruent? So now they're on a coordinate plane. I'm going to use a right triangle, thinking about the Pythagorean theorem, to figure out my sides, because I can't just count this as 1, 2, 3. That's not how we count when it's on a coordinate plane. But this is down 1 and over 3, so 1, 3. And then if I look over to this one, this is also 1, 3. So those are congruent, because if I did Pythagorean theorem, 1 squared plus 3 squared, so that's the square root of 10, and that must be the square root of 10. 1 squared plus 3 squared is c squared. 1 plus 9 is c squared, so it is c squared equals 10, and c equals the square root of 10. We're not going to get too much into that right now. I'm just trying to see if my sides are the same. So then if I look at this piece here, over to 1, 2, 3, 4, so 2, 4, and then this one is 2, 4, so those are congruent. And then if I look at this piece, 1, 2, 3, 1, 2, 3, 4, 5, and then this one's 1, 2, 3, 1, 2, 3, 4, 5. So I would say all of these have the same sides. I don't know. We'll see. Are these congruent? Okay, well, they do look like right triangles, and because they are on a coordinate plane, we can say that those are right angles. This side measures 3. This side measures 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then if you did the Pythagorean theorem, those will come out to be the same too. So again, we have another situation where we have the 3 sides all the same, but is that enough to say that the triangles are actually congruent? And here we look, and I have 1 compared to 2, 1 compared to 2, 2, 1, 2, 3, 4, 2, 4, and then this one is 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. So another situation where we have all 3 pairs of sides congruent, but is that enough? All right, so we started with an investigation, but we have to figure out what does it mean for two triangles to actually be congruent to each other. If they're going to be congruent, all 3 sides have to be congruent, all 3 angles have to be congruent, and it's important that we have to add another word, corresponding to both the sides and the angles. All 3 sides that match up, corresponding means match up like we saw with congruent angles. All 3 sides that match up have to be congruent to each other, and all of the angles that match up have to be congruent to each other. So it's going to look something like this. This is our complete picture. We have 3 angles that are all congruent and 3 pairs of sides that are all congruent. If we took this yellow one and we just slid it over onto the blue one for a transformation called a slide, they would fit exactly. So congruent you can think of as same shape, same size. Can't be bigger or smaller, has to be the same size too. And if the triangles are congruent, we need to be able to write a triangle congruent sign. We've done it before with segments. We said segment something is congruent to segment something. So now we have the triangle notation. But the order that you pick your letters in is really important. So when you go around your first triangle, you can go in any order you want. But then when you go around your second triangle to collect the letters, you have to make sure they match up and that they're corresponding. So if I'm starting with A has the 1 arc on it, and that matches to D. So triangle ABC. So that means I'm going over to B across the 2 and then up to C across the 1. It's going to be congruent. Well, A corresponds to D, and then I went across. So I'm going to go across to the 3/, which is E, and then I'm going to go up to F. And then if you go back and check, does A match D? Yes. Does B match E? Yes. And does C match F? Yes. So the order is important. Those triangles are not always going to slide nicely onto each other. You can see they don't here. These are actually kind of symmetrical. If we dotted the line and folded the paper, we would see that they would match up. So when you write your triangle congruent statement, you can start with any order. I'm going to just, because this is a 1 arc going to a 2 arc, I'm going to go like this as I collect my letters. So I'm going to say triangle RST. I'm going to start with R, go up to S, and then come down. So R corresponds to X. So we say this is going to be congruent to triangle X. Notice I went across my 3 mark, so I'm going to go up this way to W and then come on down and collect the Y. And that is my triangle congruent statement. A lot of kids don't know what I mean after we've been doing this for a while. I say write a triangle congruent statement. It means you set the 2 triangles congruent to each other in a specific order that their parts match up. So let's try it here. We've got all of the markings. My triangles are a little rotated so they don't slide nicely. I am going to go, and again, you can do it in any order that you pick first. Sometimes I just like to pick alphabetical order. So I'm going to go A, B, C. That means I'm starting with my 1/ for my angle and my 2 for my side. So let's see. That means I'm going to start at my 1 angle, which is L, and I'm looking for the 2/. So I need to go like this to collect my letters. So I'm going to say triangle ABC is congruent to triangle LMN. Triangle LMN. That's going to help us figure out some stuff after. Let's try it again. Now we have a little bit of color coding. They won't slide right on top of each other. I'd have to rotate and flip a little bit. I am going to start with my 1 arc Q and go across my 2 side, and I'm going to go around like that. So my first triangle would be triangle QPR, and then that corresponds, Q corresponds to J. Be careful, don't go across your 3 side. I picked my 2 side to go around, so I'm going to go like that. So this is going to be congruent to triangle JLK. So 2 triangles are congruent if all corresponding sides are congruent. Also has to be true, all corresponding angles are congruent. So that means 6 parts because we have 3 pairs of sides and 3 pairs of angles. And then when you write your triangle congruent statement, order matters. And let's do this one more time. We did A, B, C. I'm going to collect D, E, F. Now let's just separate them. This will be our last little bit. Separate them and tell me all the 6 pieces. I'm going to start with the angles, and you can use either the picture or the triangle congruent statement. I want to show you how the triangle congruent statement works. So because we did pay attention to order, that means it's going to line up nicely. So I can match my first letter and my first letter, and that's going to be my corresponding angle. So I can say angle A is congruent to angle D. I'm going to go with my second letter, which is B and E. There's B, there's E. So angle B is congruent to angle E. And then my third letter, C, goes with F. Angle C is congruent to angle F. Now, let me just erase that. Getting a little bit messy. And I'll switch over to blue. Now we're going to concentrate on sides. And it's definitely easier to see it in the picture. You can just see your 1/, but again, I want to show you how it works with the letters. So if I start with the 1/, that means segment BC. That's going to be the last 2 letters, so that's going to go with EF, which is true. So segment, remember to use that segment bar over top, no arrowheads. Segment BC is congruent to segment EF. Then I'm going to go to my 2, and that's going to be AB. That's going to go with DE, my first 2 letters. So segment AB is congruent to segment DE. And then this one's a little tricky, but AC goes with DF, my first letter and my last letter. Segment AC corresponds to segment DF. I will tell you, if somebody said segment CA, then they would have to say segment FD. Order matters. So 2 triangles are going to be congruent if all the corresponding angles are congruent and all the corresponding sides are congruent. When you write your triangle congruent statement, make sure you're matching them up because order matters. Nice job.